Hello and welcome. In this video, we're going to explore three fundamental data structures in C# that are absolutely essential for efficient and robust Unity game development: arrays, lists, and dictionaries. These are core concepts that every game developer should master. Understanding when and how to effectively use each of these data structures will not only greatly improve your coding efficiency and readability, but also significantly enhance the overall performance and scalability of your Unity projects, leading to smoother gameplay and more manageable code bases. Throughout this tutorial, we'll break down each data structure with clear, simple explanations and provide practical, hands-on examples that you can easily follow along with in both Visual Studio and Unity. Our goal is to make these concepts accessible and immediately applicable to your game development journey. Let's start our deep dive with arrays. An array is a fundamental data structure that represents a fixed-size collection of elements, and a crucial characteristic is that all elements within an array must be of the same data type. This fixed size and homogeneous nature are key defining features. To declare an array in C#, you specify the data type of its elements, followed by square brackets, and then the array's chosen name. For example, to declare an array that will hold integers, you would write int myArray. The square brackets are what signify it as an array type. Once declared, you can initialize an array with a specific predetermined size. For instance, myArray equals newInt 5. This statement creates an array named myArray that is capable of holding exactly 5 integer values. It's important to remember that this size cannot be changed later. Alternatively, you can initialize an array and populate it with values directly at the time of declaration. For example, int myArray equals 1, 2, 3, 4, 5. This concise syntax both declares the array and assigns its initial elements, automatically determining its size based on the number of values provided. You can access individual array elements using their numerical index, which always starts from 0. So, myArray0 would retrieve the very first element in the array, which is the value 1 in our current example. Similarly, myArray4 would access the fifth element. In Unity, we can create a simple C# script to demonstrate array usage. For instance, we can declare a public string array to store the names of various power-ups available in our team. We can then easily iterate through this array to access and print each power-up name directly to the Unity console, showcasing practical application. Arrays are particularly useful and efficient when you have a collection of data where you know the exact number of elements you need to store right from the start, and you anticipate that this collection will not need to be resized or have elements added or removed frequently during runtime. Consider practical scenarios such as storing the 7 days of the week, which is a fixed set of data. Another example is storing the exact number of players in a fixed size team, or defining the predetermined number of levels in a game, where the count is known and constant. Beyond single-dimensional arrays, C# also supports multi-dimensional arrays, which are excellent for representing grid-like structures or matrices. For example, int, my2 equals newInt 3, 3 declares a two-dimensional array that can store integers in a 3 by 2 grid, perfect for game boards or tile maps. Now, let's shift our focus to lists. A list in C# is conceptually similar to an array, but it offers a crucial advantage: it's dynamic. This means you can easily add or remove elements from a list at runtime without needing to predefine its exact size, making it much more flexible than a fixed-size array. To effectively use lists in your C# scripts, you must include the system, collections, generic namespace at the very top of your script file. This namespace provides access to generic collection types, including the list, class, which is fundamental for dynamic collections. You declare a list by specifying the data type of its elements within a value, which is known as a generic type parameter. For example, list int mylist equals newList int creates an empty list that is specifically designed to hold integer values. Adding elements to a list is incredibly straightforward and intuitive, thanks to its built-in methods. You can simply use the add method, passing the element you wish to include. For instance, mylist add will append the integer 10 to the end of mylist. Lists provide a rich set of methods for flexible manipulation of their elements. Beyond that, You can use insert to add an element at a specific position, remove to remove the first occurrence of a specific boundary, and remove that to remove an element of the index, offering precise control over your connection. In Unity, a common and highly practical application for a list is to manage a dynamic inventory system within your game. With a list, items can be seamlessly added when picked up by the player and removed when used or dropped, providing a fluid and responsive inventory experience without worrying about fixed capacities. Lists are exceptionally well suited for situations where the number of elements in your collection is expected to change frequently during gameplay. This includes managing items in a player's inventory, dynamically tracking all active enemies currently present in a scene, or efficiently handling a queue of events that need to be processed sequentially. While lists offer great flexibility, it's important to be mindful that frequent resizing, especially when adding many elements one by one, can sometimes incur performance overhead. If you have a rough estimate of the maximum size your list might reach, pre-allocating capacity can help optimize performance. Finally, let's explore dictionaries, a powerful data structure that stores data in unique key-value pairs. Each key within a dictionary must be unique, serving as a distinct identifier, and it maps directly to a corresponding value, allowing for very efficient data retrieval. Just like lists, dictionaries are part of the generic collections framework in C#. Therefore, to utilize dictionaries effectively in your scripts, you'll need to include the system, collections, generic namespace at the top of your C# file, ensuring access to this versatile data structure. You declare a dictionary by specifying two generic type parameters within angle brackets, the type for its unique keys and the type for its associated values. For example, dictionary string int my dictionary equals new dictionary string int creates a dictionary where string keys map to integer values. Adding elements to a dictionary is done using the add method, where you provide both the unique key and its corresponding value. For instance, my dictionary add will store the integer 5, accessible by the string key apples. One of the primary strengths of dictionaries is their ability to quickly retrieve values using their associated keys. For example, if apple count equals my dictionary, apples, will efficiently fetch the integer value 5 that is mapped to the key apples, providing direct access to the data you need. Dictionaries are highly optimized for extremely fast lookups based on their unique keys, making data retrieval very efficient. However, it's crucial to remember that attempting to access a value using a key that does not exist in the dictionary will result in a runtime error, so it's good practice to check for key existence first. In Unity, dictionaries are incredibly useful for managing various game settings. You could use a dictionary, string, float to store settings where string keys like difficulty or volume map directly to their respective float values, allowing for easy configuration and retrieval of game parameters. Dictionaries are the perfect choice for scenarios where you need to quickly retrieve specific data based on a unique identifier. This includes storing player profiles where a player ID maps to their data, managing complex game configurations, or creating efficient lookup tables for game assets or localized text. So, to summarize, when should you choose each data structure? Use arrays primarily when you have a fixed, unchanging number of elements and require highly efficient access to those elements using their numerical index. They are best for collections whose size is known to be constant. Opt for lists when your collection of elements needs to be dynamic, meaning it can grow or shrink in size as elements are added or removed during the execution of your game. Lists provide the flexibility to manage collections that change over time. And finally, choose dictionaries when your primary need is to quickly and efficiently look up specific values based on unique keys, rather than dynamic values. They excel in scenarios where you need to associate one piece of data with another for rapid retrieval. By thoroughly understanding the distinct strengths and weaknesses, as well as the appropriate use cases for each of these fundamental data structures, arrays, lists, and dictionaries, you can write significantly more efficient, robust, and maintainable code within your Unity games, leading to better game performance and easier development. Thanks for watching this comprehensive guide. Now, take what you've learned and actively experiment with arrays, lists, and dictionaries in your own Unity projects. The best way to master these concepts is through hands-on practice. Happy coding and game developing!